Hey, welcome back for part 3 of the distributive property. I'm your host. Just kidding. All right. Sorry, I'm a little silly this late. Okay, let's get going. Lesson 11. Let's do it. All right, go ahead and go to joinmyquiz.com and enter code 383469 so you can play the game. And then I'll go over one of the problems that was a little tricky for some of you guys. And it was so similar to the exit ticket. So I definitely think after these two problems, you're going to get this concept. All right. Hopefully you were able to play. Let's go over that problem. And I just want to say, those of you that are taking the time to make sure you're playing the quizzes games and make sure you're actually solving the problems out from the video in your notebook, you guys are having a lot more accuracy with your exit tickets. And I'm definitely noticing you guys improving a lot. So those of you that are doing it, keep it up. It's totally worth it. You guys are going to be ready for 7th grade. Those of you who haven't been doing that yet, you can get started today. All right. Not too late. All right. So the question that was the trickiest for you guys was this one, question 5. Choose the expressions that do not represent the total area of the triangle. Select all that apply. So we're picking more than one here. Okay, so it might be helpful for me to see which ones would match this, right? So for like this, I have t times 5, so that'd be 5t, and t times 4, 4t, 5t plus 4t, that would definitely represent the total area. Now, I can't add the lengths to get the area, so this one does not represent. Remember, I'm selecting the ones that do not represent, okay? If I added 5t plus 4t, I would get 9t. So 9t does match that diagram, which means it's not an option for this problem. For this problem, I'm picking the ones that don't match the total area. Okay, 4 times 5 times t. Now this one does not match because 4 plus 5 is 9, right? And this length here, another way to write this would be 9, not 4 times 5. Oh wait, sorry, I got mixed up. So I know that since this does not match the area, I choose it for this problem. Okay, now another way to write that would be t times 5 plus 4, the quantity 5 plus 4. So this one does match the area of that rectangle, which means I can't choose it for this problem. Okay? I hope that helps. It's a little bit backwards. Definitely the next one's a little bit more easy to understand. So go ahead and jot down any notes you want to from this problem. When you're ready, we'll move on. All right. Okay, so exit ticket. If you haven't had a chance yet, definitely hop over to that exit ticket slideshow and see your comment on that one. And when you're ready, press play and I'll go over it. Okay? All right. So just like last time, there's a couple different ways I can describe it. And this time, I'm selecting all the expressions that represent the large rectangle's total area. Okay? So I'm looking at this whole thing and I'm selecting the ones that do match. So this one's much more straightforward than the last one. For this part here, I can write a couple different ways, right? I have 5 times b to find the area of this, and that's equal to 5b. And then I could add 5 times 3, and I know that 5 times 3 is the same as 15, right? I can see now there's another way I could write this. I could simplify it to 5b plus 15. I could think about it as multiplying 5 times b plus 3. And I could also, for this one, I could switch the parts and I'll still get the same total, right? So it's commutative property of addition. I could have 15 plus 5b. Switch them around there. All right, so let's see which ones over here match something that I have. 3 times 5 plus b. This one was really tempting for a lot of you guys, okay? But it's important to note that, like, say I had a rectangle like this, and one side was 4 and one side was 6, okay? I could split this 4 into a 2 and a 2, right? Now, I can't do 4 times or 6 times 4 times 2, right? Those 2's are a part of that 4, okay? I can't like, say I split this up into like a 1 and a 3, right? I can't multiply 3 times 6 plus 1. That doesn't work. That's not the same thing. That won't get me the same solution as 4 times 6. There's 1 plus 3. I don't know if that helped or if it made it more confusing. But you can't just like rearrange the numbers any way that you want. Okay, you have to like stay consistent with the sides. All right, so we know this side here is like our length, right? And that's b plus 3. 5 and b are on different sides of that rectangle. You can't rearrange it like that. All right, 5, one side, awesome, times b plus 3. Yep, that was an option that we had right here. 2 is correct. 5b plus 15. Yep, right here, we have that one, correct. 15b plus 5b, we flipped them around. That's also correct. This one was also tempting for a lot of you guys. And this one was confusing for me why some of you guys would pick this one, because there's 2 3s in here, right? We see that one of our sides is b plus 3, and the other side is 5. So I wasn't sure where this other 3b came from. You could multiply 5 times b, and you would find the area of this rectangle here, right? Then you could multiply the 3 and the 5 and find the area of the little rectangle, right? But there's never a reason why you're multiplying the 3 and the b. The 3 and the b have to be added because they're on the same side. So that one does not match, okay? So go ahead and jot down any of these notes that you would like. Press pause to do that. When you're done, press play and we'll move on. Okay. All right, today we're going to practice writing equivalent expressions by using the distributive property. So we're still working on those same skills, and we're just going to fine tune and really get good at it today. Today's goals are to use the distributive property to write equivalent expressions with variables. So let's go ahead and look at this warm up. I want you to take a look at this rectangle over here. And we have a rectangle with dimensions of 6 centimeters. So the 6 is right here. And W centimeters is partitioned into 2 smaller rectangles, right? So we had the big rectangle is made up of 6W, right? And then they broke it up, they partitioned it, they split it into 2 smaller rectangles there, right? Okay. Explain why each of these expressions represents the area in centimeters squared of the shaded portion, so of this part right here. So why are these both correct? And they are both correct. Think about why they're both correct. Go ahead and think about that for a minute. When you think you've got an answer, you can press play and we'll go over it. All right. So thinking about this large outside area here, I could find the area of this rectangle, the blue one, by multiplying 6, the width, times W, the length, and I would get 6W, right? Then I would need to subtract out another smaller, that white rectangle right there, right? If I know that this side is 6, I know that this part here is also 6 because opposite sides in a rectangle have the same length. So I know this smaller rectangle here is 24 because 6 times 4 is 24. So I could use 6W, the whole area, minus 24. This one right here, right? Another way I could think about it is to call this whole length here is W, right? So I could start off with W and then know that this length here is the same as W minus 4 because I started with W and I took away 4. And then if I multiply 6 times the quantity W minus 4, I'm just finding the area of this shaded rectangle here. So that's why this one works. All right. So those two have the same value. And we call this, sometimes we'll call this like factoring out a 6, right? Because there was a 6, like you could think of this problem as being written as 6 times W minus 6 times 4, because 6 times 4 is 24, right? So we saw that they're both being multiplied by a 6, pulled out a 6, and then you had W minus 4. That's another way to think about that. Okay, go ahead and jot down anything you want from this slide. When you're done, press play and we'll move on. Okay, so we went over that already. Back from the olden days when I used to lecture in front of a whole room, we would break off and discuss. Okay, let's go on to a matching problem. So if you have your workbook at home, you're on 11.2. If you don't, just solve these problems in your workbook. No big. All right. So I want you to go ahead and pause this if you're ready. If you're not, I'll go over one with you, and then we'll go over all of them together after we're all done. This should probably take you about 10 minutes, okay? So you're going to match each expression in column 1 to an equivalent expression in column 2. If you get stuck, consider drawing a diagram. So when they say a diagram, you could draw like a tape diagram, or you could draw like an area model kind of thing like we've been working on. All right, so go ahead and pause here. Really do it. And try and match as many as you can. When you're done, press play and we'll go over it. All right, so for number like column 1A, I thought about multiplying that A. So like if I had, I won't show you the diagram for each one, but like if I multiplied A times 1, I would get 1A, which I write as A, plus A times 2 is 2A, A times 3 is 3A. All right, in my head, I instantly combined all these, but you didn't need to for this one because if you look down here, number 5, that same problem there. Cool, cool. All right, I'll try and change up my colors so I don't get all mixed up. So for this one, you could have, you want to show that you're multiplying both of them. So it's like 2 times 12, which you could also flip. And you could probably, a lot of you guys multiplied it out, but you didn't have to for this. They just want to see another expression that was equivalent, not necessarily to evaluate it. So I did 12 times 2, 12 times 2, minus 2 times 4, or 4 times 2. And the reason why I'm flipping them is because I noticed right here that this one would match. Okay, so let's go on to part C. 12A plus 3B. Okay. So I'm looking for something that would get to multiply these by 12A. So I noticed that the 3 times 4A would be 12A, plus 3 times B would be 3B. And I connected those two. All right. Ooh, this one's a little tricky. Okay, so you could do 2/3 times 15, cross cancel, be a 5. 2 times 5 is 10. So this would be like 10A, and then 2/3 times 18 minus 18. And I could take out a 3 and this would become a 6. 6 times 2 is 12. So I should have 10A minus 12. And yep, right there. Keeping you on your toes with these fractions and decimals in here, huh? All right. So I have 6A plus 10B. And I see here that 2 times 3A would be 6A. And 2 times 5B would be 10B. Cool, cool. All right. So for this one, I have 0.4 times 5. I know that 4 times 5 is 20, so I know that 0.4 or 4/10 times 5 would be 2. Minus this one, I don't want to multiply it out. It's probably going to be this one, but that's okay. 0.5 times 4, and that's going to be 20, carry the 2. 4 times 2 is 8, plus 2 is 10, decimal. Okay, and then this is actually 0.4, not, sorry. I had 2.5 times 0.4. 4 times 5 is 20, carry the 2. And I realized this after I set this up, but it's kind of the same thing as 25 times 4, right? It's 100, and then move the decimal 2 places. So hopefully you didn't multiply it out like I did. Ugh. Silly me. Okay, 4 times 2 is 8, plus 2 is 10, and then I would do the decimal point once, twice, and I'll get 1. So it'd be like minus 1a, but that's actually the same as 2 minus a, which is right here. Okay. Last one, 2a plus 3a. And I know some of you guys automatically just drew your line up there because you're like, oh, perfect, I'm done. Okay, but for this one, you could have thought, all right, I'm multiplying both of these by like an a times the quantity 2 plus 3. Or you can flip that, and you can write it as 2 plus 3 times a. This way is way less common, though. You'll definitely see the a first more often. But that's still technically correct. Okay, cool. Hopefully you got these. Go ahead and jot down any of this that you want to. When you're ready, press play. We'll move on. Okay, so writing equivalent expressions using the distributive property. So that time they were all set up for you. Now we're going to have to try and find some of those equations more on our own. And again, if you get stuck, go ahead and draw that diagram. So this time you're going to, and I'll do one for you, come up with the expressions that could match. So for this one, right, I'll draw the diagram to show you what I'm talking about. I have 3 times 3 plus x. Two different parts there. 3 times 3 is 9. 3 times x is 3x. So then I could write my equivalent expression would be 9 plus 3x. Okay? For this one, I'm thinking, okay, what common factor do 4 and 20 have? I know that 4 is like 4 and 1, and 20 is 4 and 5. And I just thought that the 4s would be the same there. So that's kind of why I decided to use 4 there. So you would factor out a 4 from both. 4 times, I need 4 times 1x or x minus, let's leave a minus sign there, and 5, because that's your other factor. Go ahead and pause here and try and fill in the rest of this chart on your own. When you're ready, press play and I'll go over it with you. All right. So for this one, maybe you had something like this whole length here is 9, right? And then you just want to find the shaded region. You know, this part is 5. You know, this side is x, right? So this whole thing is 9, and you know this little part is 5. What's this part? It would be 9 minus 5, right? Which we know is 4, but when the numbers are more difficult, we might not just know it right away, right? So I would do x times 9, 9x, minus x times 5, or 5x. That would be, and I could solve that or I could not solve it, but I could simplify a little bit more, and I would get 4x, because 9x minus 5x is 4x, or I could simplify it here, 9 minus 5 is 4, right? Okay. All right, for this one, you're multiplying both of them by x. That's the common factor they have. So I would factor in x, and I'd do x times 4 plus 7. Okay, all right. I'm going to multiply out that 3. 3 times 2x is 6x. 3 times 1 is 3. 6x plus 3. Right? Okay. 10x minus 5, I can see the common factor they have is 5. 5 times 2x minus 1. Okay, here I can see they all have an x in common. I'd factor out an x plus 1, because x times 1 is 1, plus x times 2, because x times 2 is 2x, plus x times 3, because x times 3 is 3x. All right. For this one, I would multiply them out. A half times x is x over 2, or 1/2 times x, minus a half times 6, 1/2 times 6 over 1. I can cross cancel, and that would be a 3 and a 1. I'd be left with 3 of x divided by 2 minus 3. Okay. I would multiply that y out, and I would have 3xy. Now, we haven't really seen this yet, but when you multiply like two variables next to each other, you write them like this. So like y times 3x can be rewritten as 3xy. So remember that this means that with a number next to a variable means coefficient, which means they're being multiplied. And with the variables, we put them in alphabetical order. That's just like the conventions of how we write it. So then you do 3xy plus 4, and because that alphabetical, you do 4yz. Okay. Don't worry, you won't have to solve this for two different variables yet. Okay. So for this last one here, I can see that they all have a z in common. So I would factor out a z. Z times, I'm going to give myself a little bit more space to write this one. Okay, I'll this one over here. Z, that's not a z. Z times, and then I'm going to write everything except for the z. 2xy minus 3y plus 4x. These are all being multiplied by z there. So that one would go right in there. Okay. Go ahead and jot down any of these that you didn't get. When you're ready, press play and we'll move on. All right. So today you got a lot more practice using the distributive property to write equivalent expressions with variables. I know you guys are ready to rock this exit ticket. Okay. So today you're using the distributive property to write an expression that's equivalent to 12 plus 4x. And then you're going to draw a diagram to show how the two expressions are equivalent. For that, I'm expecting to see that area model diagram that we've been using in this unit. Okay. So when you're ready, go ahead and on a piece of paper or on the slide, go ahead and solve it. And then go over to your class's exit ticket slides. Go ahead and start a new slide for yourself. Press the write your name on the slide. There's one kid that hasn't been writing their name, so make sure that you're writing your name, okay? And then go to the image and use the camera to upload a picture of your work. I will leave that question up for you guys. Have a great day, and I will see you soon. I'll talk to you soon. Okay, bye.